Alright, so a little quick video for you just to review about permutations and combinations and factorial. To me, I think the easiest way is to start with factorial and then work my way toward the other two. And so back in the day, I taught kindergarten a couple times for subbing, and it was kind of crazy. And I remember showing up and, and doing stuff, and the little kids were getting so frustrated because, you know, that's not how Mrs. So-and-so does it. So I went to line up for recess. You know, these little kids line up at the door, and they all went to recess, of course. And the idea is that, you know, a normal person doesn't think about what order they get in, but little kids matter to them. So if there were 6 kids lined up at the door, they could line up in order. There's 6 choices for the first kid, and then after you choose him, he's out. So now there's 5 choices, and then 4, and then 3, and then 2, and then 1. And order matters here, and so this is what we call 6 factorial. Now, my TI-89, the place to find that is simply here. Everything you want to know is under the, so second, number 5, that's the math key, and then 7 is probability. So factorial, then I kind of messed up, and I want to go 6 factorial right there. So 6 factorial, and so there it is, so 720. There are 720 ways these little kids can line up at the door. But what if I'm only taking 3 of them? Well, and I would have 6 choices, and then 5 choices, and 4 choices, of course, for those 3 slots. Now, this actually seems like it looks a little like that. Well, it is. It's related to it. And so this is what's called a permutation, because order matters again. And so the order for the, if you want the actual formula, it's NPR, is 6 factorial, well, it's N factorial, over N minus R factorial, which is 6 factorial over 6 minus 3, which is 6 factorial over 3 factorial. Okay, and that's how it's done. Of course, your calculator has the ability to do that simply by doing this. So you just do 6, 3. And where to find that again in the 89 is, you're going to go to second, math, 7 for probability, and then NPR, and then it's 6, 3. 120. Which makes perfect sense because that's 20 times 6. And then you're like, well, we're not going anywhere. I'm giving out 3 prizes, but they're all the same, so like pencils. So it doesn't really matter what order you're drawn out in. We're not like saying we're giving a trip to Mexico or Acapulco, and the next trip, and the next prize is a dilly bar at the Dairy Queen or something, and then the next prize is a pink eraser or something. Order matters in that case, right? But in the case of 3 pencils, they're all equally the same. So we were going to do a combination this time. And the idea of the combination, and I only show this to show that you can see how they're slightly different, but they're all related. This is a permutation. Now what we're going to do is we're going to divide out by R again, because it's the idea of we're getting rid of all of the repeats. Okay? So if I said to you, there's 6 kids and I want to choose 3 of them. So it'd be NCR 6, and order doesn't matter. Okay, it'd be 6, choose 3. And what that would look like is, again, same situation. So second, math, probability, and CR 6, 3. Boom. And there's 20 ways to do that. Which makes sense because originally it was 120, and then you're dividing by 3 factorial, which is 6. And 120 divided by 6 gets rid of all the repeats. These 20 here are legitimately different ones. Okay? And so the idea is to keep in mind is this. This is, when you think of factorial, you're thinking order matters, and I'm taking all of them. Okay? 50 people, we're choosing all of them. Well, then it's 50 factorial if order matters. Okay? By the way, if order doesn't matter and you're taking 50 people and you have 50 people, there's only one way to do that. Okay, that combination of 50 choose 50 there's only one way to do it. The permutation is that idea that I'm taking some of them, but yes, still order still matters. And then combinations, that idea of, hey, you're going to reach in a bag and grab some stuff, and you don't really care what you get per se. You're just pulling stuff out. It's something that happens a lot with combinations. You hear the word committee. Right? If you just want some warm bodies to be involved in something, that's when you use a combination. You don't care that if someone's the president, the vice president, and whatnot. No one's going to get their feelings hurt or whatever. They're just on the committee. Okay? And so I hope that helps a little bit. Give me a jingle if you need some more work on that.